The speaker is Wolfgang Gentzsch, professor of computer science and mathematics, currently president and co-founder of UberCloud. Wolfgang, the floor is yours, or better to say, Mike is yours. Presentation will concern again cloud environments and the proposition coming from UberCloud.
Great. Yeah, thank you so much. And thank you for having me. It's a great pleasure, especially also after Kathy's very interesting keynote presentation. So I would like to add a industry view with a distributed HPC technology platform for an automated self-service, truly multi-cloud simulation platform applied to a very interesting problem, which is a complex living heart simulation workflow with machine learning. And you see our project partners, everybody contributed its part to it, Google Cloud, Azure, nice TCV, remote visualization, Simulia, Abacus, and SUSE with its newly acquired Ranger Kubernetes management environment. So the middle part has been done, which is the architecture, its implementation, development and implementation by Daniel Gruber, our chief architect, and the end users are from a company in San Diego, 3DT Holdings, Jakub Dabiri, Ghassan Kassab, and Julius Guccione. And a big thanks to all of those and to all our partners. So now let's see if that works. Oh, perfect, yes. So for those who are not fully familiar with UberCloud, and let me just check, I need to position my camera a little bit, but it doesn't move. Okay, it doesn't matter, please. Let's continue. So for those of you who don't know UberCloud, we are a cloud services provider sitting on top of AWS, Azure, Google Cloud, and many more with with our fully automated, secure, on-demand, browser-based, self-service engineering simulation cloud platform. And okay, it's so here we are. Yeah, okay. I need to learn, and I try hard to learn fast. So it's about UberCloud's high-performance computing platform, and on top of that, then the application containers running on any Linux in any cloud, public, private, hybrid, and recently multi, which you will see in the presentation. And this platform and the containers are, in the meantime, used by some of the largest companies in the world. And we are an Azure partner, an AWS partner, a Google GCP technology partner, and so on. And so, yeah, let's move on to have a quick look at the engineering simulation platform. Here it says on Azure, because of the project, which is partially implemented on Microsoft Azure platform. But as you see on the bottom of this, Amazon, Google, and any others. So the top of this layered approach here is the UberCloud containers on top of the UberCloud platform. We'll go a little bit more into detail in a minute. You see standard CAE solvers, but this can also include complex workflows from manufacturing, from pharma, life science, from energy, and so on and so on. And this platform sits on a management and services layer developed or basically provided by partners like GNS in Germany or Science and Computing, a Atos company in the meantime. And the whole stack is sitting then finally on the infrastructure layer of our cloud services partners. And the whole thing, all the three layers are running in customers' cloud environments. This is very important, and I'll get back to that as well in a minute. First, let's start with the containers. As I said, CAE software containers, hosting, the engineering, simulation workflow. And if you scroll down, you see it's about multiphysics, digital twins, data analytics, AI, machine learning, natural language processing. And by the way, I just published an article on LinkedIn about a very nice UberCloud case study about natural language processing, basically written for the wider public. And then you see in the middle, applications are pre-installed, including complex workflows, etc. And on Linux, VMs, bare metal, OpenStack, which has been already nicely mentioned by Kathy, and vSphere, Kubernetes, SUSE Ranger, part of this specific architecture here, you will see in a moment. So this is this is an eye chart. I apologize for that. You shouldn't read it. I mean, but if you like to know, the major features of these, specifically for HPC developed containers sitting on Docker, yes, but 30 plus layers on top because these containers are beautifully stackable. And if you really like to get that slide, please send me an email, and I will send you the slides ASAP back. And you will see I have to run through a few additional slides pretty fast. And so I appreciate if you send me an email and just say, hey, Wolfgang, that was too fast. And send me the slides, please. So one of the newer components of this architecture is indeed SUSE Ranger. They acquired Ranger like 6-7 months ago. And it is a beautiful, I have to say that really, because we are working with it and we are having a lot of fun about all the very important big features for Kubernetes management and control of setup, control, etc. of any Kubernetes clustered environment, and sitting on top of any managed Kubernetes infrastructure, which is the beauty of that tool. And let me run to the next one. A little summary. Most of them I already mentioned. So it's these unique universal standard containers which are integrated with OpenStack, VMware, and many more running on these different clouds. And it's really one set of tools which are all integrated and like a Lego to use and plug and play, so to speak. And so then very important is that this whole stack doesn't run in any cloud provider's environment, cloud service provider's environment, but it is running in the customer's own usually discounted cloud account. So if you have, for example, Microsoft Azure enterprise agreement with Microsoft, then you get a nice discount depending on how much you commit to consume, and that discount becomes applied to whatever you consume on the HPC side on Azure. And and that's what I already said. It runs on dedicated, secure HPC servers. There's no multi-tenancy, and these servers can be spin up and shut down by the end user herself, which is really on demand. So you really pay. It's like basically a rental car model, right? So you rent it, you own it basically for the time you rent it, and then you give it back and pay for it. So customization, as I already mentioned, these very different and highly complex, partially, applications, and fully integrated and automated solution, which allows for a quick proof of concept and then cloud onboarding. Okay, so here we are already with a more detailed architectural view developed by Daniel Gruber from UberCloud. And so you have the end user part of it, which is either integrated nicely into the company's enterprise or HPC IT environment, or you can move it also already to the cloud so that you have a powerful desktop, an HPC desktop, basically, the middle layer in the cloud, from where you can spin up a ton of clusters and running a ton of applications, simulations in parallel, as we did here really with the application which I present in a few minutes, where we used 50 clusters at the same time, running 50 simulations, 6 to 12 hours for use, up to 1,500, 1,600 simulations now, which the end users, Jakub and colleagues, are then using for training the machine learning algorithm. And then on the right-hand side, so that middle part is sitting in this specific example is sitting on Google, on GCP, and the right-hand side is sitting in our own, in UberCloud's own subscription on Azure, which is basically SUSE Ranger and a few additional tools which allow for health check, monitoring, orchestration, and other things which the user doesn't really know about, but where we can remotely basically steer and control and monitor the user's environment remotely. Okay, so that was a busy one. Very quickly, I mean, the workflow, obviously, I run through that. We certainly don't have time to get to it. As soon as the user has set up the environment, she gets a welcome email, as we call it. Hello, Wolfgang, here's your login and password. And within 1 second, when the user clicks on the login, includes the password, the user is in her familiar environment, as you see here, the same environment which she's used to use on premise. As you see here, you see the little ANSYS icon as an example, and CFX. So obviously, this user is doing a fluid dynamic simulation based on ANSYS. But we are using Dassault's Abacus solver, and okay. And then the user is able to resize the cluster, to spin it up, to enlarge it, or to shut it down. So don't worry about that one here. Yeah, too much sports. Okay, so and then so finally, after everything is ready, the user shuts down the cluster or the clusters, and doesn't have to pay any more for that. And by the way, the user can use spot instances, reserved instances, or standard on-demand instances, depending on the urgency and the budget, and so on and so on. Okay, I think the next one then is, the setup. Okay, I want to skip that one. The monitoring is from Ranger, the running jobs on the left side, statistics on the right side, and still let me move on. And here is the real
between left.
Okay, I hurry. Yeah. Okay. Thank you. You're so right.
This valve actually prevents blood leakage from the left ventricle to the.
Okay, I know what happens. Yeah, there is some voice underneath. So let me run quickly through that. I basically mentioned that. Interesting is this one. For each Abacus simulation, the user it took the user about 12 hours. One simulation on GCP. When we implemented it on 2 compute nodes, it was 4 hours, and we did in the meantime over 1,500 jobs. On the workstation, it would take 750 days. On GCP, still 4 days, but this is not real time, right? So with feeding the machine learning algorithm, we were able to basically get a prediction time of just 2 to 3 seconds. with high accuracy. So let me just move on. So this is a result of the mitral valve. Basically mitral valve defects, which means it doesn't close fully anymore. For senior people, 4 million people in the US annually alone is a lot. And it's very dangerous because you have backflow and blood clogging, which might end up in the brain, where you then might get a stroke. And this can be easily done or repaired then by these mitral clips, which are intruded through the artery to the valve and fixed. But you have to find the right position. And this can be done with this approach here, which I just presented. Okay, so the machine learning is basically based on two components, which is XBoost. So XBoost stands for extreme gradient boosting, and it is an implementation of gradient boosted decision trees designed especially for speed and for performance. And then the second part of it is basically a variant of TensorFlow. Okay, running through that, the acknowledgement from Jakub to all the participants who have helped to implement it. And thank you so much. So I hope it was just in time. And please contact us either through this email or just send me an email at wolfgang.gentzsch@ubercloud.com. Thank you so much. And yeah, thanks for your patience.
Thank you. Thank you very much for the very interesting presentation, and you keep also perfectly in the time frame. So let me ask one question. If we are talking about such big environments, and distributed and heterogeneous environments, and movement of, I would say, computations between different clouds, how UberCloud is dealing with the federated approach? Yeah, I mean to keep it finally on the level of a homogeneous environment from the user point of view.
Yeah, great question. So for now, in this specific example, and the architecture has been crafted for this specific example, we do the multi-cloud approach such that the orchestration, steering, monitoring, health checking, etc., is done on Azure, and remotely then with SUSE Ranger, we basically steer and basically manipulate the user's environment on Google. But in practice, you can certainly, as soon as you don't have enough resources, for example, which recently happened to one of our customers, in fact, then you can basically then submit the other half of the simulations, for example, if you do a parameter study or whatever, and use multiple resources, then you could basically set a mirror environment up in a different cloud, on a different cloud provider, and then do the simulations then it is. It's some additional adjustment which has to be done when you spread different simulations. You cannot really spread one big simulation across a multi-cloud environment. Obviously, that doesn't make too much sense, at least these days. So that's why you basically, you have seen, we did over 1,500 simulations together with the customer. And that can easily be split into portions. Already on Google, we split it in portions of 50. 50 simply because we got 50 licenses from Dassault for Abacus. So we were allowed or able to run 50 Abacus simulations in parallel then.
I see. Thank you. Thank you very much once again for the presentation.
You're so welcome. And thank you everybody else for your patience. Bye.